Okay, so in this video, I'm going to go over zero waste, answering these basic questions. What is zero waste? And really importantly, how much waste is generated upstream by the materials we use. So uh, the first thing I want to go over here is this concept of linear resource flow, which is how we normally use resources, unfortunately. So linear, you can think of it as going in one direction and sort of having a beginning and an end. So we have extraction, manufacturing, distribution, and then your use, and then you landfill it, okay? And so that's linear, right? So it all goes kind of in a straight line, and it has a beginning point from extraction, and then it ends with landfilling. And so what's important is, this is kind of what you see of it. If you remember back to the story of stuff video, this is what you see, okay? So you see your role in it. What you don't see is sort of all of this upstream, what you consider upstream impacts of your use, right? So when you buy it from a store, and then maybe you see this part where you landfill it, but the interesting thing is, and the sort of dangerous thing is, you generally don't even see this part either. You just throw it in a trash can and then it's gone. But it's important to consider these upstream impacts. And so from the article, for every can of garbage that you throw out, there's about 87 cans of waste that was generated upstream, okay, so before it got to you. So this is really important um, in regards to the benefits of reduction, right? So, or reuse in this case. Um, if what you see in that goes into the trash is only actually a really small fraction of the actual waste that's generated from the use of that product. So this is really important to understand, and that by anytime you throw something out, there's about 90 times more waste that's generated in other parts of the supply chain. And so again, this speaks to the importance of source reduction, or you could say reuse, because if you reuse something, that means you don't have to buy it again, which means it doesn't have to be produced again, okay? And so this means you sort of have to change the whole system. And so that's the philosophy of the zero waste. So zero waste is it is a policy, it's a goal for a lot of places, whether university or a business, even whole towns like the town of Boulder, Colorado. They have this goal of reaching zero waste. Okay, and so just um, I think a pretty good illustration of the benefit of zero waste. So it may be a little difficult for you to see, but the thickness of these lines indicates the material flows in each of these steps in the process. Okay, and so this starts with this is your typical material flow, right? So you have your resource extraction, which is a line that's this thick. Okay, and this is your manufacture, your use, and then when you're done with it, what happens to it? So this is the amount that gets reused, right? So the thickness of this line, much thinner than this whole resource that you're using. Some of it gets recycled, right? So you can see that the recycling goes back into there. Some of it, this is the waste incineration, right? So you have energy recovery, so you still get some of the energy back into the waste stream. But most of it goes into a landfill. So again, you see the thickness of this line, which is about half of the thickness of this, which makes sense because about half of the waste in the U.S. is landfilled. So some of it goes into composting where you can reuse it. Some of it goes up into incineration, right? So the gases that are generated from incineration. All right, and so the key thing to understand here is that in this whole process, because we're landfilling so much of it, because so much of it ends up as gas, or some of it ends up as a gas, we have to continually extract a whole bunch of resources in order to feed this whole system. Okay, now if you sort of compare that to zero waste or near zero waste, again, so the thickness of this line, this is these are the materials that we're using. It's the same thickness here as it is down here. But if you notice the really, really big difference here, there's a couple of things. We're reusing a lot more, we're recycling a lot more, and there's actually you notice there's no landfilling here. And so there's a little bit that's composted, which means it doesn't end up back in this material flows. But if you look how thin this little component of the raw material extraction is, so compare this little bit to that amount. Okay, so when we have our typical system, which is basically like a linear flow with some, some reuse of resources, we have to continually extract a whole bunch of resources, of raw natural resources, where if we could reach almost zero waste, we could really, really minimize the amount of raw materials that we use. Okay, and so that's, I think, a really good illustration of the benefit of source reuse, also recycling. Um, but basically not landfilling. If we could achieve near zero waste, that means we achieve near zero resource extraction. And so you can think of this as what's called closing the loop, right? And so this is, our linear resource flow: extraction, use, and then wasting, throwing it in landfill. So with circular resource flow, okay, so circular resource flow, or closing the loop, instead of landfilling, what you do is you basically take the resources that you use and you loop them back into either manufacturing, or maybe you break them down, like if you recycle and you break them down into the raw components. So instead of requiring this resource extraction or raw materials constantly being used, you're taking these materials and you're looping them back in to the system, and thereby reducing the amount of raw materials that you have to extract. Okay, so that's it for zero waste.